Okay, so last time we have discussed regarding the directional relay, how the directional relay operates, what is the characteristic of directional relay, and then we have also discussed how we can introduce the maximum torque angle or the characteristic angle theta in the torque equation. So, we have discussed that the torque equation T, that is proportional to V into I into cos of phi minus theta, where theta, that is nothing but your maximum torque angle. This phi depends on power factor angle. So, it is obtained by tan inverse x by r, where x and r is the parameters of transmission line. So, we are talking about the theta, which is known as maximum torque angle. Sometimes it is also known as characteristic angle. So, I told you that whenever fault occurs, the value of phi varies from 70 to 90 degree. So, in order to achieve the maximum torque, so that relay operates for all fault conditions, we have to adjust the theta, and that we can carry out by adjusting or connecting the CT and PT such that we can change the value of theta. And I told you this theta, that can be changed, either we can set 30 degree, we can set 60 degree, or we can set the 90 degree. So, universally if I set 30, 60 and 90 degree, then the quantities that we need to feed to the directional relay, as I told you, directional relay is a 2 input relay. So, we have to give the current input and voltage input from the CT secondary and PT secondary. So, for different conditions like 30 degree, 60 degree and 90 degree, for each phase, that is R phase, Y phase and B phase, we have to give or the current and voltage to the input to the directional relay. So, if I use 30 degree connection, then for R phase I have to give IR current, and for the voltage we have to give VRB. Similarly, for Y phase and B phase we have to give IY and VYR and IB and VBY. If I use 60 degree connection, then for 60 degree I have to give the current, that is IR R phase, IR minus IY, and the voltage, that is VRB, whereas in Y phase we have to give IY minus IB, and for voltage we have to give VYB, and accordingly we have to give for the B phase. However, if I use 30 or 60 degree, any of these two connections, then for certain faults condition the relay may produce very low torque. So, to rectify that, in actual practical field they use the 90 degree connection. So, for R phase they have to give IR current, and the voltage they have to give, that is the VYB. So, here you can assume that if fault is in R phase, then we have to give the IR phase current. So, the magnitude of current is very high in R phase, and for voltage we have to give the other two phases not including R. So, we have to give Y and B phase voltage. Similarly, for Y phase also we have to give IY current and the voltage other than Y phase, that is VBR, and similarly for B phase we have to give IB current and the voltage other than B phase, that is VRY. So, by giving this values for each phase RYB, if I consider the some fault condition, let us say RY fault occurs. So, in case of RY fault, let us see how the torque is produced by the directional relay. So, as I told you, there are RY fault, so two phases are involved, one is R phase and another is Y phase. So, in R phase we have to give the quantity, that is IR, and the voltage we have to give, that is VYB other than R phase voltage. Similarly, for Y phase we have to give IY current and we have to give the voltage other than Y phase, so that is VBR. So, let us check for these values how the vector diagram behaves. So, you can see that on here we have drawn the vector diagram considering that IR, IY, IB all are displaced by 120 degree, and the voltage at this point is VR, VY, VB. So, we have the VRY voltage, VYB voltage, and we have the VBR voltage. So, for R phase, as we are giving IR current and VYB, so you can see that the current IR is here and the voltage VYB, that is here. So, if I just plot the angle between this IR and VYB, that comes out to be 90 degree. That is why this connection is known as 90 degree connection. Same way for other phases. So, in case of RY fault, if I draw the vector diagram considering voltages as reference, so we have VR, Vy and Vb voltages, all are displaced at by 120 degree. Now, whenever fault occurs, RY fault, so R phase and Y phase voltage reduces, so VR becomes VR dash and your Vy, that becomes the Vy dash. So, this two voltages reduces. The current IR, that is now in case of RY fault we have the condition, that is IR is equal to minus IY and IB is equal to 0, as the magnitude of B phase current, that is very small compared to other two faulted phases. So, we can neglect it. So, the IR current that lacks the voltage VR dash or VR, now we call VR dash by some angle, and similarly you can see that the voltage, that is IY, is exactly opposite of this IR. So, IY that comes out here, and the angle between IY and Vy or Vy dash, that is also very high, because I told you whenever fault occurs the value of phi that varies from 70 to 90 degree. So, we have to give the IR current. So, we have the IR current here, and then we have to give the VYB. So, VYB is nothing but your VYB dash, right. So, voltage VYB dash, so that is Vy minus Vb dash. So, Vy voltage you have here. So, we have the minus Vb dash voltage is here. So, if I have the Vy voltage here and Vb minus Vb dash here, so you have the voltage Vyb dash, that is this value. So, this is your V dash Yb, and angle between V dash Yb and IR, that is this angle. So, you can see that if you give this quantity to the relay, then relay will produce maximum torque. Same way for other Y phase, the Iy is the current. So, you have the Iy current here, and you have the Vb V dash Br. So, it is nothing but the you have the Vb minus Vr dash. So, Vb is here minus Vr dash, that comes out somewhere here, and if you plot you have the value V dash Br. So, angle between V dash Br and Iy, that is this angle, which is very small. So, the torque produced by the relay, that is very high. So, by utilizing 90 degree connection and accordingly if I give the input to the relay phase wise this value, that is the last row, then we can say that the directional relay produces maximum torque and there is no maloperation of relay. So, let us solve one example based on the directional relay. So, let us consider that the figure is given here. So, there are 5 relays shown in this figure. So, this relays can be directional or it can be bidirectional. So, we have to determine the plug setting and time dial setting of the relays. The plug setting of relay R5, that is given as 75%. So, this plug setting is given as 75%, and the TDS of relay R5, that is given as 0.15, right. So, these values are given, and based on this we have to find out the plug setting and the time dial setting of relay R1, R2, R3 and R4. Now, for this let us consider that the system is like this. So, if I just draw this this system again, so then we can say that the system is, we have the generator, then we have the transformer, and then we have the parallel feeder. So, these two feeders are connected here at bus B, and we have the 4 relays located here on this parallel feeder. So, these relays are R1, R2, R3 and R4, and the CT ratio of all these relays are 600 by 1. The fault level at bus A, that is given as 6 kilo ampere, the fault level at bus B, that is given as 5 kilo ampere, and then we have the another relay that is located here, that is relay R5. whose CT ratio is given as 400 by 1, its plug setting is given as 75% and its TDS value is given as 0.15. There is another bus C. So, we have the different lines emanating from this bus. The fault level at bus C, that is also given, that is 3 kilo ampere, and we need to find out the plug setting and time dial setting of all these relays. So, we have a breaker here also and we have a breaker this side also, right. So, now let us determine the plug setting and time dial setting of the relays R1, R2, R3 and R4. Now, before we start calculating plug setting and time dial setting of relays, 4 relays R1 to R4, we need to first identify which relays are directional and which relays are bidirectional. So, obviously relay R1 and R2, these two are bidirectional relay. So, I indicate with double arrow like this. The relays R3 and R4 both are directional relay because there are fair chances of reversal of fault current. So, I indicate with this arrow, the arrow that is away from the bus B. So, R3 and R4 both are directional, and relay R5, that is again bidirectional relay. So, I indicate by double arrow. So, now let us decide. So, we have the relay R1, relay R2 and relay R5. These 3 relays are bidirectional, and we have the relay R3 and relay R4, these 2 are directional relays. So, now let us start discussing how we can find out the plug setting of this relays. Now, see, plug setting of relay R5 is given as 75% of 400 ampere or 1 ampere secondary side. So, R1 and R2 we have to coordinate with relay R5 because R3 and R4 are directional. So, obviously this R5, which is a bidirectional relay, that needs to be coordinated with relay R1 and R2. So, setting of R1 and R2 both are same because we assume that CT ratio are also same, and the whatever load capacity by this line as well as this line, that is both are equal. So, let us find out plug setting of relay R1 or R2, that is greater than 1.3, 1.05 into plug setting of R5. So, if I just put the value 1.3, 1.05 into plug setting of R5, that is 75%. So, 0.75 into 400. So, if you calculate, the value comes out to be 371.42 ampere. This is on primary side. So, this is primary side of R1 R2. So, if I just divide by this value 600, so we have the secondary value, that is 371.42 divided by 600. So, the value on secondary side comes out to be in percentage 61.9% of 1 ampere. So, the higher value, higher range above this, that is 75%. So, plug setting of R1 or R2, that is selected as 75% of 1 ampere. So, this we have calculated. So, both this value, this is plug setting is 75% and this plug setting is also 75%. Now, let us calculate the plug setting of R3 and R4. So, as I told you that R3 and R4 both are directional relay, and when we have discussed the parallel feeder, I told you that R1 backs up relay R4. So, R1 will provide backup for relay R4, and similarly R2 that will provide backup to relay R3. So, obviously time of operation of R1 and R2, that is higher than the relay R3 and R4, or in another way time of operation of R3 and R4 is lower than the time of operation of R1 and R2. So, I can write down the plug setting of R1 and R2, that is greater than 1.3, 1.05 into plug setting of R1 backs up R4. So, I am writing R4 first and then R3. So, if I just change this value, if I write down in terms of R4 and R3, then we have the plug setting of R4, R3, that is less than 1.05, 1.3 into plug setting of R1 and R2. So, if I put the value here 1.05 by 1.3 plug setting of R1 and R2, we have already decided it is 75% of 600 ampere. So, we can write down it is 0.75 into 600. So, if I calculate this value primary side, that comes out to be 363.46 ampere. This is on primary side. If I divide with the CT ratio of R4 and R3, then this value 363.46 divided by 600. So, that comes out to be in percentage, that is 60.57% of 1 ampere. So, as it is less than, so we have to decide the setting next range below this. So, the below this value available, that is 50%. So, we can decide the plug setting of R4 and R3, that is equal to 50% of 1 ampere. So, this we have decided the setting of R3 and R4, that is 50%, right. So, that we can note down. Okay. Now, let us decide the time dial setting. So, as I told you that earlier case that the time dial setting of relay R5 is given, that is 0.15. So, we have to coordinate relay R5 with relay R1 and R2, because all these 3 relays are bidirectional relays, and we have to coordinate this R5 with R1 and R2 for a fault level of 5 kilo ampere. So, let us coordinate relay R5 with relay R1 and R2. So, that is first thing. So, for this with IF is equal to 5 kilo ampere, right. So, let us find out first the multiple of pickup current of relay R5. So, this is based on the 5000 ampere current divided by CT ratio of R5, that is 400, right. You can see here the CT ratio of R5 is 400 and the plug setting is 75%. So, whole divided by 0.75. So, that comes out to be the value 16.67. So, if I use this value MP of R5, then we can find out time of operation of relay R5, that is equal to 0.14 divided by MP, that is 16.67 raised to 0.02 minus 1 into TDS. TDS of R5, that is given as 0.15. So, I can put the value 0.15. So, this value if you solve, that comes out to be 0.363 second. So, required top of R1 oblique R2, that is equal to 0.363 plus 0.25, that is the minimum coordination time between two successive relays R5 and R1 or R2. So, that comes out to be 0.613 second. So, now let us find out what is the MP of R1 oblique R2 for the same magnitude of fault current, that is 5 kilo ampere, right. So, for 5 kilo ampere, that is 5000 ampere divided by CT ratio of R1 and R2. So, CT ratio of R1 and R2 is 600 by 1 and its plug setting is 75%. So, that is 600 divided by 0.75. So, this value comes out to be 11.11. So, if I use this value here, then we have the required time of operation of R1 oblique R2, that is equal to, we have calculated 0.613 second, that is equal to 0.14 divided by MP, that is 11.11 raised to 0.02 minus 1 into TDS. So, if you solve this, you have the value of TDS, that comes out to be 0.216. So, we can select the TDS of R1 oblique R2, that is the next higher range available, that is 0.25. So, we have decided the plug setting of R1 and R2, that is 0.25. 0.25. So, we can write down the TDS here, that is 0.25, and TDS here, that is also 0.25. Now, what is remaining is we need to now find out the plug setting of R3 and we have already calculated plug setting of R3 and R4. So, now we need to calculate the time dial setting of R3 and R4. So, let us coordinate here. I told you that R1 provide backup to relay R4 and R2 will provide backup to relay R3. So, obviously time of operation of relay R3 and R4, that is lower than the time of operation of relay R1 and R2. So, let us first find out what is the time of operation of relay R1 oblique R2 using this equation 0.14 MP raised to 0.02 minus 1 into TDS. TDS of R1 and R2 we have already calculated, that is 0.25. So, now we consider this value as 0.25. Now, we again the question is what is the value of MP for R1 and R2. So, for that, as we are coordinating the relay R1 with R4 and the relay R2 with R3, we have to consider the same fault level, that is 5 kilo ampere, and we need to calculate the MP of R1 and R2. So, that is 5000 ampere divided by the CT ratio of R1 and R2, that is 600, divided by its plug setting, that is 0.75. So, if you calculate this, then that value comes out to be the 11.11 we have already calculated. So, if I put this value here 0.14, 11.11 raised to 0.02 minus 1 into 0.25. So, then this value comes out to be the 0.709 second. So, this is the time of operation of relay R1 and R2 for fault current 5 kilo ampere with time dial setting 0.25. Now, as I told you that R1 provides backup to relay R4 and R2 provides backup to relay R3. So, obviously time of operation of relay R4 and R3, that is lower than R1 and R2. So, we can write down the required time of operation of relay R4 or R3, that is equal to 0.709, that is the time of operation of R1 and R2 minus 0.25, we have to subtract it. So, if you calculate, the value comes out to be 0.459 second, right. So, now we can easily find out the required top of R4 oblique R3, that is equal to 0.14 divided by MP raised to 0.02 minus 1 into TDS. So, we need to find out the multiple of pickup current of R4 oblique R3. So, that is for same fault current 5000 ampere divided by CT ratio of R4 R3, that is 600 whole divided by plug setting of R4 and or R3, that is 50%. So, 0.5. So, if you solve this, the value comes out to be 16.67. So, if I use this value here 0.14 divided by 16.67 raised to 0.02 minus 1 into TDS, and this value required top of R4 R3 we have already calculated, that is 0.459 second. So, if you solve this, the value of TDS that comes out to be 0.189. So, we can select lower value lower than this available in setting range. So, we can select 0.15. So, we have already calculated the TDS of R4 R3, that comes out to be 0.15. This is also 0.15, right. So, with this background we have already calculated the what is the value of plug setting and time dial setting of relays, that is R1, R2, R3 and R4. So, in this example we have considered both bidirectional relays as well as directional relays, right. So, with this background now let us stop here, and next time we will discuss the next philosophy, that is distance relaying scheme. So, in this lecture what we have discussed? We have discussed the directional relay, how it operates, what are the different connections of directional relay to be carried out, that is 30, 60 and 90 degree in order to set the value of maximum torque angle theta. And then we have solved one example which includes both bidirectional relay and directional relay. So, I stop here, and next time we will discuss the next chapter, that is the protection of transmission line using distance relays. Thank you.